Water, an extraordinary substance. Water is the most common and the most important liquid on the earth. If you think about all the liquids you know of, I mean, name some liquids. Gasoline, ethyl alcohol, ethanol. Boiling? Oil, okay. So those are good, different substances. A lot of times we think of, well, coffee's a liquid. Yeah, but it's a solution in water. Most of the things that we encounter as liquids are actually water with stuff in it. Gasoline and oil, ethanol are great exceptions. So, super, super important for life. It has a very low molar mass to be a liquid at room temperature. Most liquid substances like oil have higher masses. And the reason that it can do that is because it can engage in hydrogen bonding. So it's the main solvent both in living organisms and the environment. It has an exceptionally high specific heat capacity, 4.18 joules per gram degree Celsius, whereas most things are down below 1. So that allows it to moderate the climate. Another strange thing about it is that it expands upon freezing. Most things, when they freeze, they become more dense, more condensed. Water, because of its negative fusion curve, expands as it freezes, which causes a lot of things to happen. Can you guess what happened to this head of lettuce? It got in the part of the refrigerator that was too cold. Have you ever had that happen? Vegetables or fruit. It's like, oh man, I forgot I wasn't supposed to put those over there because that's the cold place, right? Things always freeze over there. It froze. Well, what happens to the cells in the lettuce when water freezes? The water expands and causes the cell walls to burst, which destroys them, basically. Now, this head of lettuce, didn't have long to live anyway because it was cut, right? But this shortened its life significantly. And so, if you're driving around and you see people with like sheets over their flowers out in the yard, it's because there's a freeze warning, right? If those flowers freeze, they're all going to die. And in this climate, a lot of times you can keep them from freezing just by covering them with a sheet of plastic or a bed sheet or something like that. I decided a long time ago that if something needs that much coddling in my yard, it doesn't deserve to live in my yard. So anything that is in my yard will freeze.
So the water just naturally, what property that makes it expand, or how does it expand?
That's a good question. How does water expand? Let's see, do we have a picture of that? No, we don't. So what happens when water freezes is that the molecules begin to line up and form a crystal structure. And that crystal structure has more space in it, and so it is less dense. And that's why we see, snowflakes and water-forming crystals. As it does that, it expands. And that can be very powerful, right? So if your pipes freeze, that doesn't happen around here, but in Minnesota it does. If the pipes in your house freeze, guess what? As soon as they stop being frozen, you've got a flood on your hands. Because as the water freezes, it will break those pipes. You may have stuck a bottle of Gatorade or something in the freezer, bottle of water, full bottle of water, right? When it freezes solid, it's going to break that plastic. So if you want to freeze things, you need to leave some space for them to expand. And some containers are better than others for freezing things. Any other questions? So we looked at a table like this recently. This is boiling point versus period in the periodic table. And so here we've got group 4, group 5, group 6, and group 7. And these are the compounds they form with hydrogen. And so comparing the boiling points. So methane is a nonpolar substance, as is SH4, GeH4, SnH4. And so these show a pretty nice line here of the temperature increasing, the boiling point increasing with the increasing molar mass. For these other guys, we see a similar trend up here, but then these guys are wonky, right? They're completely out of line. Why? Hydrogen bonding. Because for hydrogen bonding, you need fluorine, oxygen, or nitrogen bonded to hydrogen. ET phone home? So water has an oxygen-hydrogen bond, HF, hydrogen fluoride bond, and NH3, an NH bond. So these can all engage in hydrogen bonding, which means you have to heat them to a much higher temperature to get them to boil. There's also a little bit about water pollution. I'm not going to test you on water pollution, but since it's here and since we have time, let's talk about it a little bit. Of course, we need to have clean drinking water, right? Now, does our water need to be absolutely pure? No, we don't need to drink distilled water. In fact, in the long term, that would not be healthy to us. But we don't want, like, pesticides in our water, right? We don't want E. coli or something in our water that's going to make us sick. So there are two different types of pollutants, biological and chemical. So biological contaminants, as the name suggests, are going to be microorganisms that can cause diseases. And a lot of times those get into the water when animal or human waste is dumped into bodies of water. So you've got cows in a pasture near a water source, really bad idea because the microorganisms from the cow poo is going to wash into the stream. So this is why, like in the foothills, you don't want to drink the water out of that stream that you find. It might look really nice and clean, but there was a cattle crossing sign, right? There's cattle around here somewhere. Not a good idea. You can clean up the water, though, by either treating it chemically with something like bleach that will kill the microorganisms, or by boiling it, which would also kill the microorganisms. So that's one kind of pollutant. The other kind is a chemical contaminant. And this is going to come from humans, from industrial and household dumping of pesticides, fertilizers, various kinds of waste. My neighborhood is near the Kings River, and so by all the storm drains it says, no dumping, I forget the exact words, something to river. You know, it tells you, don't dump stuff here because this is going straight to the river. But then if your car is leaking oil on the road, oil's not very soluble in water, but eventually it gets moved over by the water and it ends up in the river. A lot of these chemicals are non-volatile, meaning they don't evaporate easily, and they're not alive, and so boiling doesn't help. In fact, boiling for a long period of time would make it worse because you're boiling away some of the water and you're actually concentrating the remaining chemical pollutants. Does anybody have any questions? There's really a whole branch of science around water and water safety and cleaning up water and tracking water. And yeah, if you're interested in water, you can have a really good career. And that's the end of chapter 12.